All right, I want to prove this result that I just used in the previous video. So there are a couple different ways to go about this, but I like pictures. So here's my picture. What the hell is going on with this picture? Well, the blue is the unit circle. Okay, this blue extends down here, it's the unit circle, and I have it labeled x squared plus y squared equals 1. That's important because this distance of this orange is 1, it's the radius. This is also 1 down here. Okay, I have a lot of different colors, and there's a good reason for that. I want you to pay attention to the green triangle. Okay, I'm going to compare areas. I'm going to compare the area of the green with the area of the black. The area of the black is a sector of a circle, so I'll need that formula, with the area of the orange. So let's start with, doesn't matter, the area of the orange. What is the area of the orange? Well, what I can say for the orange is that tangent of x equals hypotenuse, or sorry, opposite over 1, which means this opposite is equal to 1. I'm sorry, equal to tangent. Why is that important? Because how do I find the area of a triangle? The area of a triangle is 1/2 the base times the height. The height is the opposite. That's the altitude. So this is equal to 1/2 times the base, which is 1, times the height, which is tangent of x. What is the area of the black? The area of the black, this is the area of a sector of a circle. Okay, so the black, the area is sector of a circle, which is equal to 1/2 r squared theta. Theta is the angle, but here remember the angle is x, so r is the radius. Radius is 1, so the area of the black here is 1/2 times the radius squared times the angle, which is x. So nothing going on there. Last thing is the green. What's going on with the green? What is its area? The area of the green, again, 1/2 base times height. So all I need is the height, which is its altitude. Sine of x is equal to this h, this opposite, this is a right triangle. So sine of x equals h over 1. So h is sine of x. So this is 1/2 times the base. The base of the green triangle is 1 times the height, which is sine of x. This is looking good. Let's do a comparison with the areas of these triangles. So from the picture, we can see as a comparison is that the smallest one there is the green. So 1/2 sine of x is less than or equal to the black, 1/2 x, which is less than or equal to the orange, 1/2 tangent x. This seemingly looks like it gives me nothing, but now I will divide everything, well, multiply everything by 2 and divide everything by sine of x. So sine of x is in quadrant 1 here, right? X is in quadrant 1, which means I can divide by sine of x. I'm not dividing by negative, I don't have to switch the inequality or anything. So this tells me if I multiply by 2, divide by sine x, that 1 is less than or equal to x over sine x, less than or equal to tangent is sine over cosine. I divided by sine, so this is just 1 over cosine. This is looking like something. Now take the reciprocal of everything. Reciprocal of 1 is 1. If I take the reciprocal, I switch the inequality, is greater than or equal to sine x divided by x, which is greater than or equal to cosine of x. This is what I want. I want this limit to be 1. But wait a minute. Take the limit of everything. The limit of 1 is 1. The limit of this is unknown. But the limit of cosine, and again, I'm taking x to 0, right? Taking x to 0. If x goes to 0, what does cosine approach? Well, damn, what's cosine of 0? 1. What am I using here? Well, let me think about this for a second. If you ever think about why things in math are called what they are. This limit approaches 1. This limit as x approaches 0 is 1. This is squeezed between these two. These both approach 1. This is squeezed between. It must also approach 1. It has no choice. The squeeze theorem. The limit as x approaches 0 of 1 is greater than or equal to the limit as x approaches 0 of sine of x over x is less than or equal to the limit as x approaches 0 of cosine x, which is equal to 1. So let's see, again, this is 1, this is 1. What must this be? This must be 1. Therefore, this approaches 1. So, conclusion is by the squeeze theorem. And by the way, you should be thinking actually, if x is approaching 0, I'm only approaching 0 right now from the positive side. You need to show also that x approaches 0 from the negative side. This is not too bad. Just replace all the x's with negative x. Use the fact that sine is an odd function, cosine is an even function, and you'll get the same result. So do that. And let me just write the result here, the conclusion. So by the squeeze theorem, the limit as x approaches 0 of sine of x over x is equal to 1. Excellent. How would you prove the limit involving cosine? Maybe I should just do that real quick. Real quick. This will only take a second, actually. How would you prove the other one? The other famous limit? What if I wanted to show? I'm actually just going to use this result here. I've proved this, so why don't we use it? What is the limit as x approaches 0 of cosine of x minus 1 over x? What I'm going to do here is multiply by sort of the conjugate of the numerator. This is equal to the limit as x approaches 0. If I multiply top and bottom, okay, I'm going to multiply top and bottom, numerator and denominator, by cosine x plus 1 over cosine x plus 1. Perfectly legal, multiplying by 1. Why would I do this? Look what happens. The numerator is going to be cosine squared x. If I do the foiling up top, minus cosine x plus cosine x, those cancel, minus 1 over x cosine x plus 1. What is the numerator? The limit as x approaches 0. The numerator, cosine x minus 1, what is that? Negative sine squared of x divided by x cosine x plus 1. What the heck am I going to do here? So, this is equal to the limit as x approaches 0. You can definitely agree that sine squared x is sine x times sine x. So this is, I'm going to write this as sine of x times negative sine of x divided by x, and this is divided by cosine x plus 1. Do you see it? Let me write one more step. Limit of a product is the product of the limits. This is equal to the limit x goes to 0, sine x over x, limit x goes to 0, negative sine x over cosine x plus 1. If only I knew something about that. If only I just proved something about that. Oh, I did. So this is equal to 1. This is equal to 1. This is 1. What is this equal to? So this is 1. What is this? Let x go to 0. What does sine x go to? 0 over 2. 0 over 2, which is 0. So this is 0 over 2. So this is 1 times 0, which is 0. I'm done. All right. Like the video, comment.